I'm basically a database guy.
I grew my team from a small, like a 10-member team to 400 engineers.
PolarDB is like a cloud database.
How many best papers last couple of years?
Just 2 years, three
Yes, yeah.
best paper, yeah. So this is Alibaba heavily investing in PolarDB. Yeah, I think CXL, the ecosystem kind of going a little bit slow in the past few years, mainly because there's no hardware, because it's always hard to make a chip.
Right now, I try to explain that I had to pay like $4 or $3 per minute to call India. My kids don't believe that. What is wrong with you guys?
I think AI is changing everything.
Hello everyone, I'm Chip Engineer Lao Shi. Artificial intelligence demand for data is a two-way street. On one hand, the enhancement of AI's intelligence is inseparable from training on massive amounts of data. On the other hand, the explosion and widespread adoption of AI have brought an unprecedented flood of data to the world. Therefore, how we store, process, and retrieve that ever-expanding ocean of knowledge is the fundamental challenge that databases must address. And it is, in fact, a core proposition of our time. Today, I have the chance to speak with two experts working in this area, Raghu Nambiar from AMD and Jimmy Yang from Alibaba Cloud. They are at the forefront of technological change and are continuously pushing this field forward. We explore the past, present, and future of databases infrastructure. We talk about the revolution in chiplet technology and the profound impact of CXL on databases and how PolarDB grew from scratch to become a foundational force supporting trillions of transactions per second. We also touch on the challenges of multinational collaboration and valuable advice they shared with young engineers. I was deeply inspired, and I hope it will be helpful to you as well. Up next is our conversation. So before we dive into the technical details, I'm very curious to know how you both get into this exciting field and have been working on it for so long.
Thank you, Ken. I'm Raghu Nambiar. I've been in the industry for a very long time. So I started my career with HPE, building server and storage systems. Then I joined Cisco. When Cisco started a server business, it was 2006, 2007 timeframe. My last role was the CTO of that business. Then I was looking for exciting opportunities. Okay. Then, of course, I talked to the AMD leadership and decided to join AMD. Joined AMD in 2018. It was a very different AMD at that time. But if you look back last 7-8 years, it has been a really exciting ride. So my charter was to create an ecosystem of partners and optimize software, both the open source and the closed source software stacks on AMD's EPYC processor. So we have done a pretty good job. Today we support 75 plus ISVs and support over 300 unique software stacks. So I grew my team from a small, like a 10-member team to 400 engineers. Actually, I do have a presence in China. That is one area that we are going to invest because we have customers like Alibaba. I mean, they've been really good customer. Very close collaboration on several areas. One of the areas, of course, database that is close to Jimmy's heart.
What about you, Jimmy?
Yeah, I think I'm much simpler. I'm basically a database guy. So I started my career in a database called Sybase, which later acquired by SAP. So at that time, Sybase was, its competitor is Oracle. So after a while, I joined the Sybase competitor after Sybase got acquired by SAP. So I worked for Oracle for quite a bit of time. Then later I joined Alibaba 7 years ago. So I'm mainly working on a cloud database called PolarDB in Alibaba Cloud database business unit. So PolarDB is quite a bit interesting. We basically built it from ground up. So it's one of the largest database supplier in China right now. So we do a lot of business with I think almost over 15,000 enterprise now, so it's quite a big database. So we have a very sizable team as well, about 200-300 just for the development. So this is Alibaba heavily investing in PolarDB. So yeah.
I want to add one more thing. Actually, my experience with the databases, I've been associated with the TPC, the Transaction Processing Performance Council, for a very long time. So this is an industry standard body that brought industry standard for database performance characterization, like a TPC-C, TPC-H benchmark. So long history.
Oh, cool. That's nice. I didn't even know. So yeah.
So yeah, today's conversation is all about databases, cloud, and computing, right? So could you each describe in one keyword, in your opinion, what's the most impressive advancement in the past few years in this area?
So Ken, I don't know whether I can represent things with one word, maybe like 3 words. Okay, first one is big data analytics. I think the data revolution started in the 2010 time frame. I think one of the reasons behind that was the explosion of connected devices, smartphones and other devices generating all kinds of data. And organizations have realized that collecting and processing large amount of data can give them a business advantage. And of course, on the software side, there are technologies evolved like Hadoop and other software-defined storage system, and relational database management systems also build capabilities to run complex queries on unstructured data. So big data analytics is one. Second one is advancements in hardware technologies. Like if you look at the AMD, we brought EPYC processors to the market in 2018 with the 32 processor cores. Today, we support 192 processor cores in a chip. So the second aspect is the enhancements or advancements in hardware technologies to process the data. And third one is AI. So both the data from the big data revolution as well as the enhancements, advancements in hardware technologies are basically accelerating AI.
Yeah, I think I totally agree with Raghu. But if you want me to pick one word, I think AI is more important, even though I'm a database guy. But I think even with AI, data is most important. So where you store the data, how you train the LLM, so those kind of things are important. So databases play a very crucial role in this AI wave.
Let's talk about AI, right? So the rise of AI, both new opportunities, but also new troubles, right? Especially for databases. For example, AI brings semantic search or vector search, which makes databases more expressive, but also more technically difficult. Can you please describe in more detail about the new requirements that brought by AI for databases specifically?
Sure. I think, as we said, AI come from data and use data for inference, right? So then for database guy, we used to deal with structured data, most of because we are working on relational database. But nowadays, all kinds of different data come up, right? So it's a multimodal data. This is where we want to really handle the multimodal data. There are more videos, more kind of text, right? So there are also vector data, as you said. So there are semi-structured and structured, non-structured data come up. That's where it's a challenge for database. How are we going to store so much data? It's a large volume of data, much more than the structured data you used to have. So this is one challenge we have, and we kind of have to transform our database to be more open, to less transactional, but be able to handle large number of data, large quantity of metadata as well. I think that's one thing. Another thing is that we need to embed the AI into the database system. So make the query, make how people use AI to query the database easier. So actually we do a lot of research on natural language to SQL. So people don't need to understand and know SQL, be able to query data, right? So another thing is there are coming up a lot of agents. So yesterday, I think the keynotes, there could be more agents than people in the world. So the agents, basically, they also interact with database as well. How the database handles so much concurrent queries, right? So many agents asking questions, query the database. That's where we're looking into as well. So those are, I think, 3 main important areas we're looking at.
Thanks, Jimmy. All that requirements brings the requirements on the hardware, right? So everything will come down into the hardware. So how was the EPYC processor specifically when it was originally designed? How does it anticipate these requirements like before these new requirements are actually coming out?
When we brought this product to the market to 2017 timeframe, we introduced the chiplet architecture. Here you see this is a chiplet. The chiplet has 8 cores, 16 cores. In the future we'll have more cores. So we are able to build CPUs by interconnecting chiplets using a high-speed bus. So that way we can scale from very small, like 8 cores, to all the way up to 192 cores. So this is primarily built for the cloud. On the cloud, one of the number one criteria is how many virtual machines, how many database users or how many AI users can run on one machine. So the chiplet architecture worked really well with the compute density that cloud vendors and others were looking for. Our initial focus from a solution software perspective, it was cloud and high performance technical computing, where we have made a really big impact. If you look at companies like Alibaba, they have adopted AMD EPYC technologies actually since from a 6th generation. Right. So now we recently announced 9th generation instances powered by AMD. So now it's all about AI, right? So we have unique capabilities in AMD EPYC for support new generation of AI applications, including agents, and of course we have a very compelling GPU product line as well.
So one keyword I heard from your response is to scale out from the chip level, like by using the chiplets technology to adding more and more cores into it. And also, interestingly, from the database point of view, from especially in PolarDB, is also scale out in the cloud by building the storage computing separation architecture. I'm wondering if these two scale out philosophies seem to align perfectly. Is that a happy coincidence, or is there an inevitable technology trend like you find and can converge into together?
So I think we're all thinking in the right way, right? How do we support a large number of customers, large number of applications? So our scale up and scale out architecture is pretty much complementing PolarDB's architecture. So by the way, I'm really excited about the capabilities that PolarDB brought to the table, including winning how many best papers last couple of years?
3, just 2 years, 3 best paper, yeah.
So what about you, Jimmy?
Yeah, I think one philosophy for PolarDB is like a hardware, software co-design. So we go along with new hardwares, like AMD have this scale structure. I think we are on the same road because cloud data centers, cloud is kind of driven the whole development in the past few years. So other than AI, I think cloud is very important. So mainly a lot of business are run on cloud. So how to utilize all those resources, hardware resources, is one question. So for us, PolarDB is like a cloud database. So you have to use all the resources we have. So this is where we're coming from. It become more elastic to serving the customer. We call that serverless, but it's kind of things that use as you need, like water, like utilities, right? So that's where we have scale out. Not only scale out, we can also scale in, right? So we can scale back. So that's one thing that driven us have this whole architecture, not only separate the compute with storage, but also we separate the memory. That's where coming from the CXL story.
Okay, so what's the primary focus of PolarDB in the AI era, and what other features are added or will be added to PolarDB?
Yeah, I think of PolarDB, as I said, one important feature is serverless, like elastic. You can scale out, scale up, so multiple ways how you do that. But also, as we said, we have a lot of features coming up, we have so-called PolarDB limitless. That's where we break the TPC-C benchmark. We have the so-called 2.055 billion transaction per minute. So that's serving like 1.6 billion people buy things online at the same time. That's one thing. We want to make sure that things can scale out. One database can serve all the requirement. But we're also working on HTAP. We're working on kind of AI in PolarDB as well. So that's DB for AI features we have. So this is like people, just as you said, do more kind of vector search, more kind of NL to SQL, or they can even run their models using SQL language. So that's where we are working on.
Okay, thank you very much. So let's talk about some of the technologies like can drive hardware and software, especially database, together. One of the main technology innovation, well, personally, I think is very important is the CXL. So, but I understand a lot of our reviewers who probably don't understand what CXL is, right? But so can you please explain a bit more to our audience, like what CXL is and why it is considered to be one of the most important technology since PCIe, probably. So
CXL is a standard for connecting devices to the CPUs. It is something that AMD has pioneered. So from third generation of AMD EPYC processor onwards, we have been supporting CXL. It's all about as Jimmy said, if you look at PolarDB, right, it's a disaggregation of compute, storage, and memory. So there are many use cases for CXL, but one of the most compelling use cases, especially in the data-driven era, AI era, is the memory expansion. When you talk about memory expansion, there are two aspects. Okay, one is memory bandwidth expansion. So for many of the AI high performance technical compute applications, memory bandwidth is critical. Then there are applications like relational, like a transaction processing system where memory capacity is important. So CXL enables memory bandwidth expansion as well as memory capacity expansion.
So from a database point of view, what actual changes would that bring to the end users?
Yeah, just as I said, we try to make a database use like a utility bill. So you get a bill, how much you used. So if you look at online utilization of the CPU and the memory, it's very low. So memory, it's about 40% memory overall being used, and CPU is even lower, sometimes it's 20%. One reason is that you always pack a CPU with memory. So somebody want more memory, somebody want more CPU, but they don't go together. So that's why in one box, either memory is used less or the CPU is used less. So that's where the CXL comes in, that allow us to disaggregate CPU and memory. So people can use a little bit of CPU, but if they want a huge memory pool, that's where they can access using CXL with a large memory pool. If somebody use a lot of CPU, they use less memory, but their memory can be shared by others. So that's where making the overall TCO a lot better than used to be, right? So you can pay less because you just share your stuff to others. You give your stuff, that non-used stuff, to others. So that's where I think it's very important to the cloud database. I think not only for the cloud database, maybe even for cloud itself.
Yeah, as you mentioned, this is a absolutely critical feature, especially in the modern databases and the cloud data centers. And also you mentioned previously the core of PolarDB is the separation of the storage and computing. And you also got lots of award-winning papers in the research talking about the next step is to build a decoupled memory pool, as you just mentioned. So it seems like CXL is actually providing a perfect vehicle for achieving that vision. So in your perspective, what's the CXL-enabled PolarDB will look like in the future?
Right. I think you mentioned that we actually get a Best Paper Award for the SIGMOD. SIGMOD is a kind of international conference for database. So we just got the best paper this year in Berlin. So we talk about a CXL, how we use the CXL. Basically, CXL is kind of very tightly coupled with CPU. So CPU can access the remote memory just as if the memory are local. So that's making, it has a load store kind of instruction and make it a lot better. We used to access the remote memory use IDMA, which is a network feature. But It's kind of hard. You have to learn the verbs. You have to program with kind of NIC, all those things. But CXL brings it kind of co-design with CPUs. So we work with AMD a lot on how to make it work. I think it has advantage over IDMA, even in terms of latency. It's 10 times better. It's getting into the nanoseconds, like hundreds of nanoseconds range. But IDMA is always in microseconds. So I think that's another advantage, not only for the easy of use, but also for the latency, also for the bandwidth as well.
But what about the elastic issues? Like originally for the cloud data centers, you have to elastic to thousands, if not hundreds of thousands of users.
Yeah. I think we still work with RDMA. We're not just saying we get rid of RDMA because CXL is still more like over the PCIe. So it's more in rack communications. So if you see our machines back in the CC conference, we have the whole rack built with CXL. But cross-rack, we still use RDMA. So those we can co-evolve.
Right. So from hardware point of view, the introduction of CXL actually allows the database structure to become more flexible, allows it to have more performance benefits, and it allows people to have actually data separation. So you have hot data saved in local memory of your CPU, and also have warm or cold data stored in elsewhere. So what hardware features does EPYC processor offer to help this kind of operating systems or upper level software to manage data across different memory architectures?
Yeah, so objective here is to give full transparency from an application perspective. So application don't know whether memory is here or memory is over here, right? So we have been supporting CXL from Genoa, CXL 1.1 and CXL 2.0 in the current Turin generation. And we will be supporting CXL 3.0 in our next generation silicon. So the point I want to make is that we are 100% committed on CXL because we understand that complex applications like PolarDB needs that disaggregation and the ability to memory capacity as the application demands.
Okay, so yeah, we talk about the benefits of CXL, like in hardware is also fully dedicated to support it, but it must come with challenges. And as I understand it, one of the main challenges is the ecosystem, right? So in your vision, both of you actually, what should be done to help CXL to be more widely utilized?
Yeah, I think the hardware technology, especially from switching perspective, has to evolve. We have been working with a few companies. I mean, things are going the right direction.
So what about you?
Yeah, I think CXL, the ecosystem, it's kind of going a little bit slow in the past few years, mainly because there's no hardware. So hardware is going a little bit slow because it's always hard to make a chip. So we're working with kind of some startups and to actually develop the first CXL switch this year, actually. So this is I think it's kind of one breakthrough. Even our a best paper is based on this new CXL switch. And for us to driven this ecosystem, I think the best is to use it. So we're going to build a fleet of CXL servers. So that's where everybody can start to use CXL memories. That's where I think everything will take off.
So thank you. So I think today's conversation is a great demonstration of how hardware and software teams can, make things together. So with your team focusing on defining the chips for the future, and with Jimmy's teams actually maximizing the capabilities and how to use it to provide the true value to the end users. So I'm wondering if there's any examples, any future area like both of your team will work together in the future.
So, there is very close collaboration with the Jimmy's team. We are looking at opportunities to optimize both hardware and software. So we have a joint roadmap. Of course, CXL memory expansion is one area that we are jointly working on. Other area is I think we should work on demonstrating like a super high performance of PolarDB on AMD EPYC based instances.
Yeah, I think we just met Raghu last week in Silicon Valley. So we met Raghu very often. So not only in China, but also back in the US. I think both teams are very closely because Raghu has a sizable team in Shanghai as well in here. So they do a lot of support. Also, any questions on even for the CXL, how work with CPU, Raghu, the full team is in support, not only from here, but also everywhere, I think, in the world. I very appreciate Raghu's support on that.
Thank you. Actually, I want to compliment you for the great work you have done on PolarDB.
Thank you.
So it's a truly commendable.
Yeah, it's actually my follow-up question. So I'm very curious on like how you both teams work on a day-to-day basis. Because from my understanding, cross-globe collaboration, especially from two different companies, can be very challenging. Can you share some examples of how your teams work close and collaborate together?
That's very interesting. So we have a team in the US. Same thing, Jimmy. Right? It's sometimes it's a challenge, but if you look at today's collaboration tools, there are significant enhancements. So I don't feel that it's two different continents. It's many cases like one company, one team coming together very, very quickly.
Yeah. I think it just as Raghu says, we kind of have like a virtual task team working on particular projects, maybe the CXL projects. So we have our local engineers working on that, and Raghu has a dedicated kind of team supporting us. So any question we have, any problem we have, and we can talk to each other and get it resolved very quickly. So I think
another thing is we have visibility into longer-term roadmap. So many surprises. Our objective is to minimize the number of surprises. Having a close roadmap alignment is really helping us a lot.
So firstly, we need to have a very close future vision, and also we need to work very closely.
Yeah, because chip development years, like 2-3 years, how to get it mature is also important. So and a lot of feature you have to plan in advance, and the problems we have maybe will affect their next generation design. So that's, I think, very important to work together.
Okay, thank you. So let's look into the future, right? So for the next 3 to 5 years, in addition to AI or CXL we're talking about today, what are the other emerging technologies or application scenarios do you see will impact, especially on the database design, and what's next for PolarDB?
I think we actually looking at a lot of interesting area, but it's kind of built on top of AI and the database. We're looking at a kind of in-memory, close memory computations. So once we have CXL, we have CXL switch and CXL controller. A lot of even vectors computation can push down to the memory or push down to the storage. So that's where I think we are closely looking at it, because Google has TPUs, right? They also have this processing capability. So we're actually also looking at those more innovations in terms of close memory, close storage computations.
So a similar question for you then. What's the next thing for, especially for hardware?
I think it is going to be AI, hardware acceleration to support larger language models, and also emerging other applications emerging in the AI world. So we truly believe that AI is going to change the world in a good way, and our strategy is to build the best product to bring efficiency to support emerging AI applications.
A lot of my viewers is actually very young people, passionate engineers entering the career. So you both have brilliant careers, and starting from different but converging to small but common places like you're working on together. Your experience, I think, will be very inspiring and to the people who are watching this interview. So the question we ask for every interview is that if you were just entering your career like 10 or 20, 30 years ago, what's the most important piece of knowledge or skills you wish you have back then at that time?
So I think that the new generation is very, very lucky. Possibilities for them, it's endless. So I give this example. So when I was in the US in the 90s, my number one expense was rent. Number 2 expense was phone calls. So right now, I try to explain that I had to pay like $4 or $3 per minute to call India. My kids don't believe that. What is wrong with you guys, right? So the technology has changed a lot. So like, for example, internet. Internet is as a topic that nothing new, okay? Like for 10 years ago, it was very different, right? So now, for the new generation, like they have the data available. You don't have to go to libraries to look for something now. Everything is available online. Second thing is there are a lot of opportunities for online training. So whether it is AI or databases, right? There are a lot of online trainings available. The next one is AI, right? That is going to change the world, and the new generation has a lot of opportunities to shape the future of AI.
I think AI is changing everything. So I don't have a definite answer for how to tell them what's going to look like in like 10, 20 years into their career. From my old past experiences, like I think you spend enough time to explore all the possibilities and find something you are passionate about and stay with it and build a career out of it. So that's where I think you stay in something and build into if you're really good in some niche market or some niche skill, you're going to get rewarded. So that's only my thing, but AI is going to change everything. So
actually, I think for the new generation, right, there are way more opportunities today than it was like 20 or 30 years ago. The thing is, like, you need to take advantage of opportunities available to you. I think one advice is work hard. There's no compromise.
Thank you very much, Raghu and Jimmy, for today's conversation.